Preventing crevice corrosion in new and existing steel bridges. This presentation will be by Eric Shoyer.
Well, thank you. Good to see everyone. Thanks for coming to the presentation. I will try not to go too far into our break. I know it's coming up soon, so I will try to make this right on time. I do apologize if I go a little quick. I am born and raised in New Jersey. It's in my blood, so I will try to slow it down a little bit. Again, my name is Eric Shoyer from LZ Technology. Along with Pete Olt from LZ Technology, we're the authors of this presentation titled Preventing Crevice Corrosion in New and Existing Steel Structures. So kind of the basis of this overall presentation, a little bit different from probably some other ones we've seen or you might see this week, is I'm just going to show you basically this 1-year laboratory study we did looking at some of the best ways that we found, or even kind of results we thought might have been the best ways to prevent crevice corrosion, again, on new and existing steel structures. So kind of a really loaded question on new and existing steel structures is what's the best way to treat them? And depending on who you talk to that day, you can get an hour's conversation, a 1-sentence answer, which way is going to be the most effective. So we looked at numerous different samples. Why we looked at numerous different samples is, as you can see from the background I have up here, is if new structures are being applied to a bridge, again, all of us are here know what bridges look like with many of the crevices, all the bolts, veined surfaces. Mark mentioned in his presentation earlier, it becomes very complex to coat and really prep these areas so that running rust, pack rust, really you're not going to see start to happen early on after, say, a repaint job has been completed. So for new structures, sorry if I'm standing too close to the mic, one would think to apply mating surfaces with zinc rich or primer prior to application would be the most ideal, most suitable scenario to help corrosion not to happen early on. Though for many of us who've been in a construction process or been there when new steel is being added to an existing steel, this is not always able to happen. This is not always going to be planned, even though we might try for it. Additionally, in existing steel structures, stripe coats, amounts of caulking are used, how many different stripe coats at which part prevent crevice areas from really showing that corrosion. And though effective, caulking can be expensive, and then how much caulking is actually needed? Do we need to caulk an entire bridge at every single crevice to really make sure we're not going to have any rust occurring? So for some visuals of what I'm talking about, a little bright in some of these slides, as you can see some of the, this does work, okay? Some of the crevice corrosion happening at these areas with steel bolted together that just really weren't treated properly. And I would like to tell everyone this was over a long period of years. This was in a period of months after a recoated job. So if it's not treated properly on an existing area, you can see what I'm talking about. Now, here's a different example of, this is a few years old, this actually application. You can see there's actually a little hard to see from this photo. There were stripe coats and some caulking applied to this area, so no rust was able to be seen. However, on this same exact bridge, some areas where running rust were found, some corrosion was happening, just because these areas weren't treated properly. So my main task for this project is, again, it was a laboratory-based study. We looked at 20 different test combinations that looked at aged, new steel, that last line right here, different types of surface preparation. We looked at abrasive blasting, we looked at power tool cleaning, abrasive blasting prior to assembly of some panels. And to throw in just another wrinkle, we looked at different types of fastener material, black oxide and galvanized. Caulking extent, how much caulking worked, how little would still have an effect. And coating sequence, though we looked at the same type of coating system throughout, that standard 3-coat system, that zinc, epoxy, urethane, very common in the Northeast, is we looked at the application of stripe coats when adding them, how that had an effect. So after we had all of our test assemblies, which I'm going to talk about in the next few slides, they were exposed to cyclic accelerated corrosion testing. We evaluated them for rust staining, blistering. Then at the very end, we disassembled to look at how much actual localized pit corrosion happened between some mating surfaces. So kind of to replicate some of the scenarios I showed you on those few first slides of those photos, we came up with a test panel design. It was a 6x12 by 1/8 steel panel. It had 3 2.5 by 4 inch steel panels bolted onto them, as you can see right here. to create an intended crevice, an actual little gap for water penetration during our corrosion testing. And we had this L angle right here, this 4" by 2" to try to capture some water when the panel was exposed for our accelerated testing. And as I mentioned, just because we wanted to take another look at things that we do see sometimes in our construction process, is we took a look at these 10 bolts here. Sorry that this slide actually shows it a little better. These 10 bolts right here were all black oxide. These 10 bolts to the left were all galvanized. So the test matrix is we had 20 panels, 10 of which panels, again I'm going to repeat this the next few slides and I'll do a recap before we go into the results, were new steel. Of those new steel, we had some that were assembled, abrasive blasted, SP10. We had new steel panels that were abrasive blasted and as individual parts, and then they were zinc primed prior to assembly, so really getting those mated surfaces. Then we actually weathered some steel, which I'll talk about in this next slide. We abrasive blasted SP10 prior to coating, and then some of them we did SP11 prior to coating, just to show some repair scenarios we'll commonly see sometimes in the field. So of those 5 different surface preparations, there were 5 panels that went throughout. 1 panel did not receive a stripe coat or any type of caulking scenario. 1 panel from each system received a stripe coat with no type of caulking scenario. And then we had 3 panels that all received stripe coatings and a different version of the caulking scenario, which I talk about in a few slides. So how do we prepare aged steel? Again, 10 panels were assembled, coated and pre-weathered. We only coated these panels with 3 mils of epoxy, so very light. We were trying to really replicate and show corrosion to happen in a quick, limited time frame. To do that, we subjected them to 150 hours of ASTM B1117 salt fog, and then we did some outdoor exposure testing right outside our facility in Vineland, which is South Jersey area, for 9 months. Prior to coating application of that 3-coat system, the 2 different types of surface preparations we looked at. First one was an SP10. So here's a sample that was weathered in SP10, near white metal blast. And then the SP11 power tool, this was done by needle gun and grinding wheel. The other panels, the new steel, and I mentioned that we had assembled some steel panels. That's this photo right here. It seems the one to the right has a little better brightness. So we would assemble the panels, then SP10, this scenario, and then we applied with the 3-coat system, again that zinc epoxy urethane. And then for half of the new steel, they were actually blasted, zinc primed, then assembled, and then treated with the epoxy urethane system. So a big thing I want everyone to note is that the bolts were only scuff sanded prior to an intermediate coat. They did not receive the zinc coating system. So the coating application we followed, pretty standard system that we see from our areas, that 3-coat zinc epoxy urethane system. We did that one of the either SP10s, as I mentioned, abrasive blast, or power tool cleaning SP11. All panels were given a solvent wipe prior to coating application. We did a zinc prime 3 to 5 mils, zinc stripe, except 1 panel from each one of those pre-weatherings and surface prep did not receive any of these stripe coatings. Intermediate coat, intermediate stripe. This is where we applied that caulk, where we have 3 different scenarios, which I'll talk about in a sec. Our finished stripe 3 to 5 mils, and our finished coating system. Moving on to the different type of caulking scenarios, we looked at 4 different caulking scenarios. A full method, right here, where we hit every single crevice on these panels. Okay, there is not an area untouched we didn't touch with caulk. 3/4, we actually left the bottom of each panel exposed, and why we consider this the bottom is how the panels are oriented through our corrosion testing. You'll see that this is actually going to be where moisture would be able to leave these areas. We have the top caulking scenario as well, and then none for some of the panels that had absolutely none, again leaving some of these crevices open to see just a kind of performance-based difference. So what type of performance testing did we do? Okay, the corrosion testing was GMW 14872. For those not familiar with this test, one cycle of this test consists of 8 hours of 4 different salt sprays, 8 hours of 100% humidity, 8 hours of a dry-off high elevated temperature. That is one cycle in this test, and we did 120 cycles, so really put these panels through a lot of, sometimes we'll say, torture testing on those coatings. We did visual inspections at 20, 40, 80, and 120 cycles. We did inspections ASTM D610 for rusting, 714 blistering, crevice corrosion locations, so when crevice started to occur at these when corrosion started to occur at these different crevices. And also we did on counting the rust bolt count. Really what we wanted to see is how much was corrosion starting to occur on all of the bolts, black oxide or galvanized, at the different inspections, how quickly it would start to occur throughout our testing. At the end of the testing, all panels were disassembled, and that's where we did our pit analysis to really determine that localized corrosion, really see how much metal was lost in between those crevices. So I know I've thrown a lot of information at you in the last few slides, a lot of different information, so I just want to do a really quick review before we even start to go into the results. So we had 10 panels that were assembled, coated, pre-weathered. They had 3 mils of epoxy, 150 hours of salt fog, plus 9 months of outdoor exposure. Those panels, half of them received Abrasive Blast SP10, half received SP11 power tool cleaning. And then we had 10 panels that were new steel, 5 were assembled, Abrasive Blast, then coated again with our zinc epoxy urethane 3-coat system. 5 panels were Abrasive Blast, zinc primed, then were added the epoxy urethane. Again, noted the bolts did not receive an intermediate coating. And then 3 different caulking methods were used on each one of those systems for each preparation scenario. And all panels were exposed to 120 GM 14872 testing. So now on to the interesting fun slides. Hopefully everyone can see. These are our results throughout our testing, and if you look on the left side, this is our primed after assembly. These are all our new steel panels. Primed before assembly. Going from the top to the bottom for each table, I have no stripe, no caulk, so this was just applied with that 3-coat system. This had that stripe coat all the way around, however I had no caulking applied. Stripe plus only top coat in all these scenarios, so you can start to see some of that running rust happen from these crevices. And then stripe plus 3/4 caulk so the bottom is left open, and stripe plus the full caulk all the way down here. Same for the prime before assembly, and I know your eyes are really going to be drawn to really these top lines for all the corrosion happening around these bolts. Remember that these bolts did not receive a zinc prime or a zinc stripe. These were scuff sanded and received just an epoxy, especially this top layer didn't receive a stripe at all, received the benefit of a stripe in really some of these systems here. Results for our weathered steel. For the left-hand side, same similar scenario. We have our no stripe, no caulk up on the top for both tables. We have our stripe, no caulk for our second line, stripe top caulk, stripe 3/4 caulk, and stripe full caulk system. And I definitely forgot to mention this on the last side. Going from left to right, this is our first inspection at 20 cycles, next inspection at 40, next inspection at 80, and next inspection at 120 at the end of test. Apologize for that. To the left, you can see the SP10 panels compared to SP11. And really where I noticed this is around some of those crevices where the SP10 abrasive blast on weathered steel compared to SP11. You see a little bit less running rust happening from some of these. No surprise, you start to see a little bit of more corrosion on some of the bolts on the SP11, just because the cleaning you're able to get with a needle gun or a grinding wheel probably not as effective when you're actually getting an abrasive blast. So this graph here, I want to go through just the results of the black oxide bolts. Okay, from these we took a count of each one of the panels of how much was just starting to display corrosion. Now that doesn't mean 100% of every single area of the bolt was displaying, it was just how many bolts. So if all 10 were displaying corrosion for a panel, okay, that would give it 100%. So the big thing noticing here is this system is our new primed before assembly, so these bolts did not receive that zinc primer or zinc stripe. It's just almost this whole entire system by the end of test is most of the bolts panels primed prior to assembly really displaying that corrosion, as I note here in this second bullet. Definitely less evident on abrasive blasted panels than power tool. That's this scenario, the power tool right here. This is our weathered system. And I even took a look at the galvanized bolts. So the main thing is really here a lot less red compared to the black oxide bolts. Not a whole lot of surprise here, but one of the big things is definitely we see more red start to happen on this 5 panels, where this is where we had the system that did not receive that zinc stripe, just had the scuff sand before the epoxy, clearly showing the benefits of striping the galvanized bolts. So at the end of all these inspections, the real fun part was getting to rip these panels apart and really seeing what is happening between those crevices. So going from left to right, no stripe, no caulk, stripe plus no caulk, stripe top caulk, stripe 3/4, and stripe full. This is our new primed after assembly, new primed before assembly, weathered SB10, weathered SB11 panels. So one of the big things here that we noticed is that the 3/4 caulking applied to new steel that's primed after assembly, so this is right here, showed to actually be better than a full caulk system. You can see that all the corrosion is just evident. Even the prime before assembly seemed to really hold moisture. Now for the weathered panels under repair conditions, there clearly was a benefit to a full caulk system compared to a 3/4. You can see actually some of the steel was still not really completely pitted through. The remaining caulking schemes visually did not repair better, so just the addition of stripe plus top coat really did not have a clear benefit over 3/4 or full caulk. However, you can see the benefit of a stripe coating pretty easily compared to a non-stripe coating. So visual evaluations are great. Something else we wanted to grab was a pit depth analysis of those areas. So to better quantify the actual crevice corrosion, the pit depths, is we looked at 2 different surfaces on each panel. We gathered 10 measurements at each of these areas to find the highest pit depths, determine how much actually metal and corrosion happened. And before we actually took the pit depths, skip that second slide, we used abrasive glass bead to get away all the rust and pack rust that happened. So that L bracket right here, and the larger plate were the 2 areas we picked on each. The L bracket, this area, that was where glass bead blast was done. You can see right here. And the larger plate, this is before and after, where 10 measurements were taken to really see how much corrosion and metal loss happened throughout this testing. So for some results, pit depth on the L bracket, for all the blue, that is the primed before assembly, the green, that is primed after assembly, I have my weathered steel and I have my new steel. For the weathered steel, pretty clear benefits, that's the bars go down from moving to left to right, no stripe, no caulk, stripe only, top caulk, 3/4 and full, having the lowest average. Though the top and caulk only here for the SB11 had a lower overall average, but you could see just in general the stripe and full had the less amount. For the new steel, the prime before assembly had a clear benefit on the lowest type of pits being taken, and even at the 3/4 for both the prime before assembly and prime after assembly had the lowest pits taken overall. It's that middle crevice area, so moving to the middle for the weathered steel, showing the least amount of pit depth, done by the same as last slide. This is the SB10, SB11, with the full caulk system with the stripe coat. And then on the new steel, we have our prime after assembly and prime before assembly. The real big benefit is showing that prime before assembly in that middle area, almost no pits measured at all. And showing the benefit of that 3/4 caulking and full caulking compared to not applying it on those crevices. So, conclusions that we came forth, at least to this evaluation: galvanized bolts perform better over time compared to the black oxide bolts. If black oxide bolts need to be utilized during the construction phase, proper surface preparation along with stripe coat we found definitely helps prevent corrosion to occur if you do not apply these. Stripe coats and caulking on crevices directly exposed to water and moisture help prevent corrosion on the steel. However, consider using that 3/4 method compared to a full caulk system to allow moisture to escape. When working with weathered steel, definitely a full caulk system is found to have the best results in reducing crevice corrosion. As best practices, if you're ever putting new steel onto an existing area, to get a zinc primer on, or a primer in general prior to application should be pretty beneficial. Just some acknowledgements here. Special thanks to Pete McDonough, Brian Pazanka from the Tri-Road Bridge and Tunnel Authority for supporting this work done by LZ Technology.
On larger bolts, where we've had on the Skyway Bridge struts that connect to the cable stays, those were problems as far as corrosion developing on the bolts and nuts. These are good-sized bolts, probably 3/4 inch diameter, maybe even an inch, I don't recall right off. But many years ago, our Gainesville lab suggested we use a cover for those bolts and nuts, a little slip cover, grease-filled. And that actually, as far as the bolted connection, that would include the crevice under the bolt head or the nut, plus the nut head itself, bolt head. And again, those have been kept in place over many years and indeed succeeded and stopped seemingly, for some strange reason, aggressive areas of corrosion over, say, surrounding areas. This localized corrosion. So that's a method there that has worked well in this application, very corrosive environment.
Were your bolts properly tightened? Or did you, your bolts, were they properly tightened?
Torqued down?
Yeah.
Yes, they're all torqued to the same. I don't know off the top of my head, but we did torque them down to one of the specifications had a requirement. So it was actually the same torque.
Based on your study, would you say where pack rust exists is sufficient to do the blasting, caulking, and three-coat paint, or the assembly, would it be required for connections? For connections where you have pack rusts, based on the study that you did, would you say the assembling the connection is required, or blasting and caulking and three-coat?
Before assembly?
Yeah, deassembling the connection.
If you're assembling a connection, at least we saw if you're able to get a zinc prime down on those mating surfaces, that really help prevent corrosion happening on that surface over time.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.